This is day 44, part 3 of linear inequation. Exercise 4, question number 11b. This is the inequation that is given. If this is the inequation where x belongs to z means integers, find the solution set. In this case, if you notice, it just says find the solution set. You just have to find only the solution as a set. You don't have to represent this on a number line. Okay. Now, if you look at this, you will see something new. There are two lines here. These two lines are called modulus. It's called a modulus. Anything which is written inside a modulus has two possible values. One is a positive value, the other one is a negative value. Like say for example, I am writing 6 inside the modulus, which means this 6 has two possible values. Because it is inside the modulus, you have whatever is inside the modulus, that is the positive value, that is 6, and the other value is just change the sign of this minus 6 is the second value. So anything that is written inside the modulus has two possible values. One which is inside the modulus is the positive value, and change the sign of whatever is inside, that gives you the other value, whatever is inside the modulus. Okay. Now, this is modulus of x minus 4, I have written this, is less than 3. The 3 is not inside the modulus. It's only the x minus 4 which is inside the modulus. Okay. So, inside the modulus you have x minus 4. So, there are two possible values because it is written inside the modulus. Okay. The first one is the positive value, that whatever is inside the modulus is the positive value. So, that's x minus 4 is the positive value. And the second value is change the signs of all the terms which are here. So, this becomes minus x and this becomes plus 4. That will be the second value. Okay. First positive value is whatever is inside the modulus, that's x minus 4, and the negative value is change the signs of all the terms that are there. So this becomes minus x and this becomes plus 4. Okay. So x minus 4 which is inside the modulus can be written as two possible values. The first one is x minus 4, so I have written that here, x minus 4 is less than 3. The 3 was not in the modulus, therefore no sign change for that. Okay. So this is the first value. The second one is the negative value that you have to use for this. So this is minus x plus 4 is less than 3. The 3 remains the same. Okay. Now to solve this, the first one is there is only one x term, so it is positive, therefore let it remain there. Take the minus 4 to the other side. So x is less than 3 plus 4, that will give you a 7. And the second one, if you look at this inequation, there is one x term, but that x term is negative. As I told you before, always keep your x term positive. So don't cancel any signs or not. Best possible way is to shift this negative x to the right side. So there is a 4 and the 3 comes this side, 4 minus 3 which will give you 1, and less than this minus x goes to the other side, becomes plus x. So both inequations are solved, and if you look at this, it says x belongs to integers. Therefore, don't combine these two results and write. You can write this as a set. So x values, therefore x value is, now read the first one, x is less than 7. It is not equal to 7. So 7 is not there. Less than 7, which means 6, 5 and so on. Read this also. It is x is greater than 1. It is not equal to 1, which means 1 is not there. X is greater than 1. Greater than 1 means 2, 3, 4 and so on. So combining these two results, this is the answer that you get as a set. Okay. 2, 3, 4, 5 and 6. Okay. And as I said, it just says find the solution set. Therefore, you leave the answer here. You don't have to draw any number. Okay. The next one. This is question number 30. The question is, if P is the solution set of this is the inequation given, and Q is the solution set of this is the inequation given. There are two separate inequations given. The solution for the first one is represented as P, and the solution for the second one is represented as Q. You will not write x is equal to something. Well, after you solve this, you write P is equal to the values of x. And for the second one, after you solve, you write Q is equal to these are the values as a set. Okay. And it also says when x belongs to natural numbers. Find the set. There's the first subdivision, it says P intersection Q, and second subdivision P intersection Q dash. We'll come to this later. First, let's solve both these inequations that are given. Okay. The first inequation is represented by set P. Okay. So I'm starting with P. Solution for P. The inequation is 7x minus 2 is greater than 3x plus 10. Out of these two terms, the two x terms, this one is bigger, so let it remain there. Bring the 3x this side. So 7x minus 3x is greater than 10, and this goes that side plus 2. 7x minus 3x is 4x is greater than 10 plus 2 is 12. Take the 4 that side. X is greater than 12 divided by 4, that will give you a 3. Now, as I said, P is the solution of this inequation, and x belongs to natural numbers, therefore you can write it as a set. So, instead of writing x is equal to, here it was mentioned P is the solution, therefore P is equal to, now read this, x is greater than 3. It is not equal to 3, so 3 is not there. Greater than 3, natural numbers which are greater than 3 are 4, 5, 6, 7, 8, 9, 10 and so on. I am not writing everything, so I put dots and close the bracket. It goes up to infinity. That's the solution for the first inequation, which is represented as P. Okay. This is the second inequation, and this solution set is represented as Q. Go to that one now. About Q. This was the inequation that was given. Let's simplify this, remove the bracket. 5x minus 1 is greater than or equal to 2 into x is 2x, 2 with 7 is 14. There are two x terms. Out of these two, this is bigger and it is positive. Therefore, bring the 2x this side. 5x minus 2x is greater than or equal to 14, and this goes that side plus 1. 5x minus 2x gives you 3x is greater than or equal to 14 plus 1 gives you 15. Take the 3 that side. X is greater than or equal to 15 divided by 3 will give you 5. That's the solution. Again, x belongs to natural numbers, therefore you can write this as a set. Okay. But the solution set is represented as Q. So Q is equal to, now read this, x is greater than or equal to 5. It is equal to 5, therefore 5 is there. Read again, x is greater than 5. Greater than 5 means 6, 7, 8, 9, 10 and so on up to infinity. So I put dots after few numbers. It's going up to infinity. So this is the solution for P, this is the solution for Q. Let's go back to the question. The question is this. First subdivision is, you have to find P intersection Q. You got P as a set, Q also as a set. Intersection means what is common between P and Q. You have to see which elements are common in both the sets P and Q. So let's check both the sets. We have P, we have Q here. Now you see what is common in both. There's a 4, there's no 4 here. That's not common. 5 is common, 6, 7, 8, 9, 10, it will go on up to infinity. Therefore, the first subdivision is P intersection Q, which is starting from 5, which is common, 5, 6, 7, 8, it goes up to infinity. That's the solution for the first one. Let's see the second question. The second question is P intersection Q dash. We found P and we found Q. But there's something else. There is a Q dash. So first thing is you have to find what is Q dash. Okay. Q dash are elements of Q. Elements which are not present in Q. Here it says X belongs to natural numbers. Okay. And you got Q. See this. This is Q. This one is Q. Okay. And X belongs to natural numbers. So Q dash are those elements which are natural numbers but not present in Q. Okay. In Q you have 5, 6, 7, 8 up to infinity. So elements which are not here are, which are natural numbers, are 1, 2, 3 and 4. Which are not here because it belongs to natural numbers. Natural numbers start from 1. 1, 2, 3, 4 are not here. Okay. Those belong to Q dash. So first thing is I found Q dash. Q dash are those elements which are not in Q. So that gives you 1, 2, 3 and 4. But the question was, you have to find P intersection Q dash. Means what is common between P, what is common between P and Q dash, this one. Okay. Look at both of them. There's a 1 here, it's not here, it's not common. 2 not common, 3 is not common. There's only a 4 which is common. Okay. So P intersection Q dash has only one element which is common, that is 4. So write that as a set.